if you eliminate all the multiples of 2, then the multiples of 3 will also be a little bit, multiples of 3 will also get eliminated. Via 2, if you eliminate 18, so when you are eliminating the multiples of 3, over there you will see 18 is already eliminated when you are eliminating the multiples of 2. Let's try to visualize this. Let's say we have all these numbers listed. Okay, in these numbers we have to find what are all the numbers that are, in this particular range that are prime. So I'll start checking from 2. I'll ignore 1 because 1 is neither prime nor composite. So I start checking from 2. I'm going to be like, hey, is 2 a prime number? It's going to be like, yeah, yes it is. So I found 2. Now what am I going to do? I am going to eliminate all the multiples of 2 that lie in this range, because obviously if 2 is prime, then all the multiples should be eliminated. All the multiples should be eliminated. I know that if 2 is prime, then 2 2s are 4, means 4 will not be prime because 2 is dividing it. Eliminate all the multiples. 4 will get eliminated, 6 will be removed, 8 will be removed, 10 will be removed, 12 will be removed, 14, 16, 18, 20, all of these multiples will be removed of 2. That, hey, you don't need to check these. Okay, whenever you land on this number, you don't need to check it. So how do we actually maintain these things? How do we maintain which number is eliminated and which number is taken as a prime number? We can create an array. So an array can contain, let's say, numbers from, let's say, index from, all the numbers like till 0 till, let's say, we can imagine these are index numbers or whatever. Okay, we can store these in an array, and we can actually keep it as a Boolean array. Okay, that is going to contain true or false. So all the circles that I'm providing in the array, these indices will be true. All the crosses that I'm providing in the array, the value of all the indices that are crossed, these are, let's say, index values we are taking, that is going to be false. Whenever you land on an index value that is false, skip it. So array will move forward. Now I'll check for 3. It's going to be like, hey, 3 is neither circled and 3 is neither crossed. So I will check, is 3 prime or not? It is. Okay, 3 is prime. Eliminate all the multiples of 3. All the multiples of 3 were what? 3 1 3 2 6. 6 is already eliminated, no problem. 9 is gone. Okay, 9 is gone. Then I have 12. So 12 is gone. Then I have 15. 15 is gone. Then we have 18. 18 is gone. Then we have 21. 21 is also eliminated. Then we have 24 eliminated. 27 eliminated. 30 eliminated. Then we have 33 eliminated. 36 eliminated. 39 eliminated. No problem. No problem. Now we go to 4. And I'm like, hey, 4 in the index value of 4 is already false. It means that a factor of 4 has already appeared in the past. That is true. 2 has already appeared. Skip it. 5. It's going to check, hey, is 5 prime or not? It's going to be like, yeah, it is it. Okay, this is true now. Index value of 5 is true. So now eliminate all the factors of 5. 10, 20, 30, 40, 15, 25 and 35 eliminated. Now 6. It's saying the value 6 is already false. It means that a factor of 6 has already appeared in the past. Something that divides 6 apart from 6 as 1, apart from 6 and 1 has already appeared in the past. That is true. 2 has already appeared in the past. 3 also. Now it's going to be like, okay, skip it. 7. Is 7 prime or not? So that's basically it's checking. And one more thing I want to share is, what is the square root of 40? What is the square root of 40? Square root of 40 is 6, around 6. Isn't this the same concept that when I'm checking, like, hey, this is the same concept when I'm checking about 40. Okay, all the things that, let's say, divide 36, we're checking 36. Would you check after 6, would you check whether 9 is prime or not and eliminate all the factors of 9? Because what is the, sorry, not the factor, but multiple of 9? Because 9 into 4 is something that is already eliminated, over here. So this check that you are making of is this number, this number, this number, it's obviously just going to go till square root. For the same reason we just did. Why am I checking till square root? Why? Because it's already explained this number. Because 9 after 6 Next, would you check whether 9 is prime or not and eliminate all the factors of 9? Because what is the, sorry, not the factor, but multiple of 9? Because 9 into 4 is something that is already eliminated, over here. So this check that you are making of is this number, this number, this number, it's obviously just going to go till square root. For the same reason we just did. Why am I checking till square root? Why? Because it's already explained. This is the reason in front of you. That is the reason I'm only checking till square root, because after that it gets repeated. Okay, so I will do this check till square root only. Now all the numbers that are remaining should be prime. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. And that is true. Above also you can see. Only check till square root. Why? Because after that it keeps getting repeated. Duplicate number. Okay, that is it. Let's code it. So I'm going to create, we'll discuss the complexity of this as well after we code it. So public static void main sieve, right? So I'm going to create another function. I'm going to say, let's say static, and let's say it's not returning anything. Let's say it's modifying the original array. This is known as sieve of erathonesis, something like that. I think that's the spelling. Sieve of erathonesis, something. rolls on the tongue. We're taking a Boolean array. So we are taking a Boolean array, let's say primes, and we're taking a number int n. Or we don't have to take the number, we can just directly pass the array. Or we can take the number also, no problem. Primes, okay. What is the size of this going to be? Let's say int n is equal to 40. Then I'm going to create my array. I'm going to say Boolean primes is equal to what? New Boolean. I am taking the number as its index. So if I'm saying 40 should be included, so if n should be included, then size should be n plus 1, because array starts from 0. If I just put n over here, then the last element will be 39, and I want n to be included. That's why I'm doing n plus 1. And I'm just going to say that run the sieve method, and you're going to pass n and you're going to pass primes in it. All right, that's it. Now what am I going to do? I'm going to say that for int I is equal to 2, I'm going to start checking from 2. This should be less than equal to n, something we've already done, and I plus plus. This is something we already done. So what I'm going to check now? I'm going to check whether, oh, by the way, initially you know that all the initially you know that all the numbers in the all the elements in the Boolean array are going to be false. Okay, all the elements in the Boolean array are going to be false. So I can say if it is false, if prime of I is false, if this is equal to false, or I can say like this. In that case, what I'm going to do? I'm going to say that this is false, so it means that I'm going to, let's say over here what we're doing is, Yeah, this is something I did not think about. So, okay, no problem. Primes is going to contain false, like, all the items. If I try to run this thing, let me just show you something. So if I say print primes of, is very simple stuff. So initially the Boolean array contains all the elements, the value will be false. Okay, you can check. False. So initially it's false. So here we can say that, okay, let's say we are saying that false in array means number is prime. Let's say we can take that. So false in array means number is prime. So whenever we find an element that is false, we can say that, okay, this is a prime number. And then make all of this. In the next few videos, we'll talk about like packages, static, non-static, singleton class. We'll talk about properties, polymorphism, overriding constructor, and special methods, inheritance types, encapsulation, abstraction, access control, object class, object cleaning, interface, abstract classes, interfaces, generics, exception handling, collection framework, lambda expression, enums, file handling, and fast input output. All of these things will be covered.
Nice.
Hey everyone, welcome back to another video, and we are starting with a new topic. So we are doing the complete data structure algorithm bootcamp, and this is a series that we're starting on now, object-oriented programming, right? So the next few videos, including this one, will be on object-oriented programming. If you haven't already subscribed, make sure you do so, and let's get started. So I'm going to teach you literally like everything about it. Okay, so I will teach you like what is object-oriented programming, what are the various principles specific to Java stuff as well, um, and we don't just because content on this you can find in so many books and stuff. So what makes this course special? I will teach you how to think. I will teach you from a beginner's point of view. I will teach you how to master object-oriented programming in a simple, easy to understand language. I will teach you what doubts you can have, because in object programming people can have so many doubts. So I will tell you this is the doubt you may be having, and we'll then look into it. So it's gonna be great. It's gonna be a really top-notch, amazing playlist. So make sure you like, share, and subscribe, and let's get started. Okay, so object-oriented programming. Okay. Before that, I want to mention about the playlist itself. So the notes will be provided, text notes, so like text files in GitHub repo. Okay, so for notes you'll be having text files in the GitHub repo, and this particular whiteboard stuff, this file is just like rough work. Okay, if there's a concept that requires for me to use the whiteboard, I will use it. So main notes can be found over here, like detailed notes. You don't have to make notes yourself. You can use the ones that I provide. Okay, focus on the lecture itself. Don't make notes. Do not make notes, because I will be providing those. Okay, so no need to make notes. So this playlist I'm super excited for this because it's going to be great. Like if you don't know anything about it, even if you know about object-oriented programming, I will literally tell you everything, and we'll also cover like in detail explanations of why things are working the way they are in Java, also inheritance and stuff, and interfaces and abstract classes and singleton class and generics, also collections framework, like, and all these other things we'll be covering. Cool. All right, so let's get started. So over here I'll also teach you about like what are packages and stuff that will also come. So we are basically going to cover like the introduction about classes and objects, the keywords like new, things like constructors, other keywords like this and final and finalized stuff like, you know, destructors and stuff, wrapper classes, packages, static, non-static stuff, singleton class, the properties of object-oriented programming like polymorphism, overloading, overriding, inheritance, the types of inheritance, encapsulation, abstraction, access control, object class, object cloning, interfaces, abstract classes, generic exception handling, collections framework, lambda expression, enums, and later on we'll also be doing like file handling, fast input output, and all these other things. This is the entire syllabus for object-oriented programming. All right, cool. But let's start with like the basic stuff. I'm just going to create another package. I'll tell you what packages are in detail later on. Okay, introduction. Okay, so what are we doing? Okay, forget about object programming. So just forget about it right now. Let me give you a problem statement. You are sitting in a class, and someone, let's say, asks you, hey, your teacher asks you, hey, please create a data type. Want you to make an application that stores, let's say, 5 roll numbers. You're like, okay, ma'am, no problem. I can just write it in Java. I can say main.java or something. Okay, public static void main. So your teacher asked you, hey Kunal, please create some sort of a data type or something that stores 5 roll numbers. You're like, okay, no problem. Roll numbers are integers, so I can just, I can just create an array. Something like this. Okay, or you can say new int 5. That's it. No problem. Now your teacher is very impressed. Now your teacher says, hey, can you please create some sort of a data structure or something that stores 5 names, right? So you're like, okay, store 5 names of, let's say, your students or something. So you can be like, okay, I want to store 5 names, so I can create an array of string. No problem. String names is equal to new string 5. No problem. Now your teacher asks you, hey Kunal, please create some sort of a data type to store what? Data of 5 students. You get confused. You're like, data of 5 students? What do you want me to include in that data? Then your teacher says, good question. So your teacher says, include the roll number, marks, and the name. Roll number, marks, and name. You're like, okay, no problem. So you can say something like, okay, if you want the data of students, so you can say data of 5 students. Every single student contains, let's say, a roll number, name, and marks. We're like, okay, how can we do this? So you can be like, okay, let me just create, let's say, 3 arrays. Roll number, right? String. Okay, something like this. And marks can be float or something. Okay, new float, something like that. Now your teacher is like, you have just created different data types for every single property. Okay, so your teacher is like, okay, this is fine, but I want it to be something like this. In just one single line, every single element, for example, in this case, every single element is what? Every single element is a name. Here, every single element is an integer. Similarly, I want some sort of a data structure in which every single element contains these 3 things. This is where classes and object-oriented programming comes in. Okay, so what is a class? What is a class now? A class, again, don't write notes. I will be providing notes. A class is a named group of properties and functions. a named group of properties and functions. These three properties that I have right now, roll number, name, and marks, if I want to combine this into a single entity, I can do that via classes. By convention, class starts with a capital letter. Okay, so your teacher will be like, okay, I don't need these three things. I need you to give me something like this, like some other data type called student, your own data type. You made it. Students is equal to new student, 5 students. Every student, like every single element in this array, should contain these three items. So one more simple definition can be, if you want to create your own data type, how can you do it? Using classes. We'll talk more about later, like when we do encapsulation and stuff. I will tell you in detail what all these things are and stuff, but please focus on basics right now. We'll cover everything. Okay, don't worry. So you're like, okay, I need to put this inside a class. Something like that. Like, okay. Then be like, I can basically then create a class. This is how you create a class. This is the syntax for it. Class, class name, that's it. That is it. As simple as that. Let's say you want to create one student first. So I can say something like student Kunal is equal to new student. I'll tell you more this new, what about this new thing is and what all these things are. Let's just forget about it right now. Okay, no worries. Student Kunal. Now this Kunal is going to have this variable Kunal. This reference variable is of type student, our own data type that we created using a class. And it consists of what? It consists this thing is and what all these things are. Let's just forget about it right now. Okay, no worries. Student Kunal. Now this Kunal is going to have this variable Kunal. This reference variable is of type student, our own data type that we created using a class. And it consists of what? It consists of three properties. Don't worry about the static stuff and stuff. I'll cover that in detail. But right now, just focus on what we are doing, not how we are doing it. Things we'll cover in detail. Okay. So here it's basically saying that it contains three properties: roll number, name, and marks. So Kunal will have a roll number, name, and marks. How to access that, how to modify that, and everything we'll cover later on. Okay. So this is basically what we mean by classes. Now let's talk about this reference variable object and how this works internally, how to update and stuff and all these other. Okay, so this is basically a template, as you can see. Okay, so a class is like it's like a logical construct. For example, this is defining what class is. What simply I mentioned to you, it's just a name group of properties and functions. You can add functions here as well. These are known as methods. We'll talk more about that later. For example, create a method that gives you the GPA of a student. Create a function like that. Okay, so let's look into it a bit more in a bit more detail. A name group of properties and functions. Okay, what else? What are some real life examples of classes? Car. A car can be a class. Okay, and using that class, using that template, so many companies are creating their classes, their cars. There's, let's say, BMW, there's Audi, there's Tesla, or whatever. Okay, so BMW, let's say Audi, and let's say Ferrari. Okay, so these are the three classes. Let me bring up my whiteboard for this. Okay, so I know that class is a name group of properties and functions. So a car class, if this is a class of a car, okay, a class is just a name group of properties and functions. Let's say I'm just visualizing it with a box. And what all properties does the car contain? A car contains an engine, a car contains the price, and the car contains the number of seats, for example. Okay, now this is a template. This is like the general stuff that every car needs to have. Using this template, many companies have created their cars. Okay, so Maruti created their own car. Okay, Maruti. Ferrari created their own car. Using this template, they're like, hey, this class is a template, like some properties and functions that every car must have, and please you follow this to make your own car. Okay, here we have something like Audi. Okay, very simple. Now what are these boxes that I'm talking about? Maruti, Ferrari, and Audi, they follow the same procedure. They have these properties, but the value of properties are different. They all have engines, but this engine is, let's say, small engine. This one is, let's say, big engine. Okay, or I can say something like, let's say I can say this is like a petrol engine. This is like diesel engine. And this is, let's say, electric engine. So all of these three cars have the same property, engine, but the value of it is different. Okay, price for example 1 lakh, 2 crore, 1 crore. Seats, let's say over here 2 seats, 4 seats, 4 seats. Okay, so using this template they created their classes. No, they created their like cars, not classes, cars. They created their cars. This is sort of like the template. You can think of it like as a piece of paper someone gave them. Okay, it's just like a standard for a car, right? Okay. Now, please try to think it in the real world sense. Does this thing like really exist physically? Like if you're saying like obviously cars exist, but this template stuff is actually like a sort of like a rule sort of a thing, right? These are the things that exist physically. When you ask someone, please show me an example of a car, obviously they're going to show you a car, right? They're going to show you something physical. One more class example can be what? That we all share in common. Human class. So human class, humans have some rules. 2 arms, like by default 2 arms, 2 legs, 2 eyes, hair, mouth, nose, ears. By default these are the rules, right? So some people have like big eyes, some people have smaller eyes, some people have a large mouth, some people have a big mouth, some people have, ears, different shape, some people have long hair, some people have short hair, right? Some people have longer nails, some people have shorter nails. So human class is also like a group of properties and functions. These are all the properties that humans should have. But who are humans? We are the ones who are roaming the earth. We have all these properties, but different people may have the different value of these properties. Are you able to understand the difference between the class and what represents the class? These things, these things are known as what? Objects. So a class is what? A class is a template of an object. And what? Instance of a class. Okay. So as we mentioned about the data type, this can be a separate data type called a class data type. And classes help us in defining this data type. Classes help us in defining this data type. So when you create an object of a class, you're actually creating an instance of that class. What is this instance? Instance means a physical stuff of that class. When babies are born, they are instance of the human class. Human class is a rule. God has provided this as a rule. Like, okay, this is the human class, this is a rule. It is not a physical thing, it's a rule. If you want to make a physical thing, you have to have a baby, right? Same thing for cars. This is a rule for cars. Engine price and seat should be there, minimum. And in order to make it a reality, the physical stuff, that is like follow this class template and create an instance out of it. That is known as an object. So object is what? So class is what? I will explain it in a very nice way. Class is just a logical construct. It does not like exist physically. Logical construct. And object is what? Physical reality. Reality. This is the thing that is actually occupying space in the memory. Actually is something physically present. Occupies space in memory, RAM, or whatever you want to make. We have been dealing with objects since first lecture. We created objects of what? Arrays, array list and stuff. All of those were objects only, right? Okay. So class is a template of an object. Object is an instance of a class. Class creates a data type that you can use to create objects. When you declare an object of a class, you're creating an instance of that class. The class is just a logical construct, and the object is the one that actually has some physical reality, that is occupies some space in the memory. Okay. That is the difference between classes and objects. Okay. Now objects are categorized by like it's like they have three essential properties. Okay. State of the object. I am not writing this down because I'll be sharing my notes. State of the object, identity of the object, and behavior of the object. So what is the state of the object? State of the object means its value from its data type. That's sort of like the state of it. Identity of the object means whether one object is like different from other. Okay, it can be useful to think as identity as like where the value is stored in the memory, right? So for example, object. So what is the state of the object? State of the object means its value from its data type. That's sort of like the state of it. Identity of the object means whether one object is like different of the state of the object, identity of the object, and behavior of the object. So what is the state of the object? State of the object means its value from its data type. State of the object. Okay. Now objects are categorized by like it's like they have three essential properties. Okay. State of the object. I am not writing this down because I'll be sharing my notes. State of the object, identity of the object, and behavior of the object. So what is the state of the object? State of the object means its value from its data type. That's sort of like the state of it. Identity of the object means whether one object is like different from other. Okay, it can be useful to think as identity as like where the value is stored in the memory, right? So for example, you already know this. I don't have to repeat it. Stack memory, heap memory, object, two two reference variables pointing to the same object. Already covered this thing. If you make a change via this reference variable, original object will be modified. Hence, the change will be visible via the second reference variable as well, if they are pointing to the same. Please watch the previous videos. Strings, arrays, everything is covered on that. Now I'm telling you why it's happening. In previous videos, I told you what is happening. I also told you why it's happening. But now I'm moving into more details. Okay. I remember in the previous videos, I used to say we will cover in object programming. Now it's the time for that. Okay, so this is like the identity, and the behavior of the object is the effect of the data type operations. For example, we'll be creating, let's say, functions and stuff in your objects as well. So you can say create a, every human should have a function called greeting. So every human, when you call the function greeting, they will greet someone. Hi, hello, something. We'll cover that later. Okay, but this is as simple as it can get. Okay. All right. So what we are doing, we just covered. What are classes, objects, and stuff, and things like that. Right. Objects are stored in the heap memory, and the reference variables are stored in the stack memory. We'll cover more details about that and things like that. Right. Objects are stored in the heap memory. And the reference variables are stored in the stack memory. We'll cover more details about that. All right. Now let's see how we can make it a reality. So how do we create objects and stuff and assign values, change values, then we'll add functions into it, then we'll cover all the other. Let's take our student example. You're like, okay, Kunal, the class is created. A class student is created like this. So a logical construct is being created. Okay, there's a student class and it has some properties like the roll number, right? It has a name and it has marks. So something we have to talk about right now is how do I actually make sure that I create like various objects, like one student Kunal, another student Rahul, third student will be like something like Anais, for example, right? So Kunal's roll number can be roll number 14, name will be Kunal, and marks will be 87.9% or something like that. Okay, Rahul's roll number can be something like 28, name will be Rahul, marks will be something like 92.7. Anais's roll number will be something like name will be Anais, roll number will be 33 or something random stuff, and marks will be 90 95.8 or 89 or something. Okay, random stuff I have just put over there. But the question is, how do I make sure that I use this template of the class to create these objects? Okay, before that I need to actually understand how do I access these things. These class properties are something that everyone will be having. We know that any object of the student class will be having these three properties: roll number, name, and marks. Okay, and we can obviously, how do we do this thing, right? How do we create an object? So before that, yeah, I need to explain to you, like, let's say, assume the object is created. Okay, don't worry about how to create it right now. Assume it's created. Let's say this object's name is KK. This is name is RR. This name is, or not KKRR, I can say this name is student1. This is a reference variable. Student2, student3. Since we have already worked with classes before, this is nothing new. Okay, you have worked with arrays, array list and stuff. So over there, what were you doing? You were saying array list is equal to new array list. This new keyword we talked about before. This is used to create objects. We'll cover more into, like in this video now we will cover in detail. Like the depth of it. Okay, we will cover the depth of it, how it's working internally. But forget about this right now. Don't need to worry about this right now. Right now, just assume these objects are created and these are the reference variables of it. How do we access this thing? Okay, what is student one's roll number? What is student two's percentage? What is student three's name? How do we actually access this? We know these students are of what type? Classes are nothing but data types. So what are these students type? They're of type student, and student has three properties: roll number, name, and marks. Then how do we access the roll number of student 1, 2, 3, and so on and so forth? Using the dot operator. Okay, so the dot operator basically links the reference variable, like the object, that the name that we have over here, student1, student2, and student3, with the name of like the instance variable. Okay, so basically like just the object properties. This one is going to link this one, the name of the instance variable, like the name of the instance variable. These are known as instance variables. What are so the dot operator basically links the reference variable, like the object, that the name that we have over here, student1, student2, and student3, with the name of like the instance variable. Okay, so basically like just the object properties. This one is going to link this one, the name of the instance variable, like the name of the instance variable. These one of student is used, and student has three properties: roll number, name, and marks. Then how do we access the roll number of student 1, 2, 3, and so on and so forth? Using the dot operator. Okay, so the dot operator basically links the reference variable, like the object, that the name that we have over here, student1, student2, and student3, with the name of like the instance variable. Okay, so basically like just the object properties. This one is going to link this one, the name of the instance variable, like the name of the instance variable. These are known as instance variables. What are instance variables? Variables inside the object, they are known. It's going to link this one, the name of the instance variable, like the name of the instance variable. These are known as instance variables. What are instance variables? Variables inside the object, they are known as instance variables. Okay, so this dot operator is going to link this with this. So when I do something like dot operator is variables. Okay, so this dot operator is going to link this with this. So when I do something like dot operator, how do we use this? When I say something like print student1 dot roll number, it's actually linking this object reference variable with the instance variable. So student one's roll number is what? This actual thing is going to give me answer 14. This is known as dot operator. Okay. Commonly we call it a dot operator, but the form in the Java it is categorized as like dot as a separator. Okay, that's like the formal definition. Okay, as this sense, student one dot roll number. It's actually linking this object reference variable with the instance variable. Are of what type? Classes are nothing but data types. So what are these students type? They're of type student, and student has three properties: roll number, name, and marks. Then how do we access the roll number of student 1, 2, 3, and so on and so forth? Using the dot operator. Okay, so the dot operator basically links the reference variable, like the object, that the name that we have over here, student 1, student 2, and student 3, with the name of like the instance variable. Okay, so no, basically like just the object, the object properties. This one, it's going to link this one, the name of the instance variable, like the name of the instance variable. These ones, these are known as instance variables. What are instance variables? Variables inside the object, they are known as instance variables. Okay, so this dot operator is going to link this with this. So when I do something like dot operator, how do we use this? When I say something like print student 1 dot roll number, it's actually linking this object reference variable with the instance variable. So student one's roll number is what? This actual thing is going to give me answer 14. This is known as dot operator. Okay. Commonly we call it a dot operator, but the form in the Java it is categorized as like dot as a separator. Okay, that's like the formal definition. Okay, but you can call it a dot operator as well. That is it. You can now use this to access any instance variable. So global object and name using the dot operator. Okay, so the dot operator basically links the reference variable, like the object, that the name that we have over here, student 1, student 2, and student 3, with the name of like the instance variable. Okay, so no, basically like just the object, the object properties. This one, it's going to link this one, the name of the instance variable, like the name of the instance variable. These ones, these are known as instance variables. What are instance variables? Variables inside the object, they are known as instance variables. Okay, so this dot operator is going to link this with this. So when I do something like dot operator, how do we use this? When I say something like print student 1 dot roll number, it's actually
Blockchain developer. It is one of
actually linking this object reference variable with the instance variable. So student one's roll number is what? This actual thing is going to give me answer 14. This is known as dot operator. Okay. Commonly we call it a dot operator, but the form in the Java it is categorized as like dot as a separator. Okay, that's like the formal definition. Okay, but you can call it a dot operator as well. That is it. You can now use this to access any instance variable. So these are known as instance variables. These all variables are instance variables. All the variables that are inside your object, they are instance variables. The variable that actually defines an object, something we already covered. Array list is equal to new array list. String name is equal to Kunal. So this list, this name, these are what? Reference variables. We've already covered reference variables before. We've been doing this since so long, right? Reference variables you already know. Okay. So let's talk a little bit more about that, how we can work with this. Okay, so these are instance variables, variables that are declared inside the class. Since so long, right? Reference variables you already know. Okay, so let's talk a little bit more about that, how we can work with this. Okay, so these are instance variables, variables that are declared inside the class, but it should be outside the method and the constructors and stuff that we'll talk about. Basically, just like this, outside the class. Oh, sorry, outside the method, but inside the class. Okay, so I'll talk more about instance variables in detail after giving the example. Okay, so bear with me for a second. Okay, so here I can say that I have my student class. I've just put it outside the main class or whatever, and it has just, I actually did a not so good copy pasting over here, because it will not be an array, right? It will just be like int roll number. That's it. String name and float marks. That's it. Okay, uh, because the array that we want to make is of the students collectively. This is a data type for every single student. Okay, for every single student, like this, every single student has a roll number, name and marks. So if I create a student like this, okay, how do we actually make sure that these things are like modified? So for example, if I try to print it right now, if I say Kunal dot roll number, try to print that, you can see it's saying, giving me an error. Variable Kunal might not have been initialized. Let's talk about this for a second. So in order to create these objects, you have to use the new keyword. Okay, so let's talk about the new keyword a little bit more. Again, it will be again available in the notes, so don't worry about it. Everything will be given in the notes, so you don't have to like really make notes or anything else. Okay, so let's talk about the new operator. What does the new operator do? So if you have a student class like this, if you have a class student, it has three properties: int roll number, string name. Now we're talking about how to actually create objects, and float marks. Okay, this is what you have. This is a class. How do I create objects from this? This is a data type, student. So it's going to be obviously student over here, like we do array list. We do array list. You can give a name to the student. I can say student number 1. do array list, you can see it's saying, giving me an error. Variable Kunal might not have been initialized. Let's talk about this for a second. So in order to create these objects, you have to use the new keyword. Okay, so let's talk about the new keyword a little bit more. Again, it will be available in the notes, so don't worry about it. Everything will be given in the notes, so you don't have to like really make notes or anything else. Okay, so let's talk about the new operator. What does the new operator do? So if you have a student class like this, if you have a class student, it has three properties: int roll number, string name. Now we're talking about how to actually create objects, and float marks. Okay, this is what you have. This is a class. How do I create objects from this? This is a data type, student. So it's going to be obviously student over here, like we do array list. We do array list. You can give a name to the student. I can say student number 1. This is my reference variable. Okay, now in order to create an object, now what is this thing? This is actually known as, like, you are declaring the reference to the object. Okay, so you are here declaring it. Declare this reference variable to this object, to an object of this type. This is actually not creating an object. Okay, this line that we have over here, this one, this is basically just a reference to an object of type student. At this point, the student number 1 does not yet like refer to an actual object. Okay, it is just in the stack memory like this. Stack memory, we have the stack memory, we have the student 1. That's it. Some people may ask, Kunal, okay, this reference variable is in the stack memory. You have not created an object, whatever. You have just declared it right now. Then what is it pointing to? What is it pointing to? Before asking such questions, try to print it. You'll find the answer yourself. Let's see. Let's try to print it. Okay, so let's try to see if we try to print this, what will happen. Right now, by default, it's just going to say that it is not initialized, for example, right now. Okay, that is what it's going to say. So when it is like not initialized, it will ask me to, hey, initialize it, and by default it will do it as null, for example. Okay, but let me do something else. Let me say that, okay, this is an array of students, right? This is an array of students. So let's try to do one thing. Let's try to see what is inside this array. If every element in this array is a student class type, then what is the type of that thing? Print arrays.toString students. Let's try to print and see what we get. Null. So when this is not initialized, the student, when it is not initialized, by default the value is what here in Java? Null. For primitives it may be different. We'll talk more about that later. But for objects it's null, as you can see from this example. Okay, all the students here are null. Now let's talk a little bit more about that, like how we can actually create this object and stuff, and by default if it's null. So here you can see that this is declaring. So this is actually just, we are just creating a reference of type student. But if we want to actually create an object of this. We do it like this. We have done this before as well. Student1 is equal to new type student, like this. So this new operator, it actually dynamically allots. What do we mean by dynamically allots? Very important point. Allocates the memory at runtime and returns a reference to it. Okay, so let me write this down. I'm telling you everything, how things work. Dynamically, you are responsible for working with the nodes and everything. Okay, I'm putting out knowledge out there. Dynamically allocates, but I'll mention this on my notes as well. Dynamically allocates memory and returns a reference to it. Reference variable to it. Okay, which is going to be stored here in student1. Okay, a reference to it. Okay, that is it. And this reference is stored in this student1 variable. That is how it works in Java. The objects are stored in the memory, heap memory. So this is the heap memory. An object of this student type will be created like this.